All right. So we'll kind of go through this page by page. Did you guys get a chance to check most of the key? Okay. So I would say if you have a question, ask. But if it was able to be resolved from looking at the key, then obviously I think you're okay with it. We'll probably need to save time, maybe go over some of the ones that you weren't so okay with. All right. So as we kind of go through this, I screen captured them slide by slide as far as mine goes. I have 1 through 6 on the first slide. Does anybody have questions on 1 through 6 they'd like to discuss or ask about? Adjacent angles, linear pairs, drawing out in segments, bless you, segment addition postulate, midpoints. No questions on 1 through 6? Going once? Twice? All right. How about on 7 through 11? 7 through 11. I have it up there. So while you're looking at 7 through 11 to decide if you want to ask, number 7 I put up there because it's not using the midpoint formula. It's using what I call the shortcut, where if you're given the midpoint, you just have to find out, okay, my x is changed by 9. I should go by 9 more to get the other x value. My y's went down by 1 to get to the midpoint. I should go down 1 more to get the other endpoint. All right. Any other questions on 7 through 11? It's being very quiet. Second period asked about note cards, and I think we talked about it. There's no note cards for this one. If I were you, as we go through this, if there's something you forget, I think I talked about this already, but write it down on a piece of paper in your notebook. Like, man, I really forget how to write a converse. All right, and it had P's and Q's in it, or inverse, or contrapositive. I need to remember that. Or I forget the midpoint formula. I should probably remember that. Or the slope formula, or slope intercept form, or point slope form. Those are the kind of things. If you want to, if you don't remember it, write it down so that you know what to study. All right, Grace.
On 11 on the key, it said 54, but isn't it obviously above 90?
Why do you say obviously?
Because it's obtuse. DEF. And it said 54.
You remember early in the year how we said don't go off of looks with the picture?
When I solved it, I was like, I don't know why I got it wrong then. Because I don't really know. I got that one wrong, but I didn't know if it was like written down wrong or something.
Gotcha. So the whole idea of that, and I completely understand where you're coming from. The frustrating thing about geometry sometimes is that we don't base diagrams off of looks. Now, are sometimes they kind of look correct? Yeah, sometimes they do. Do you guys remember section 5.8 that we just did that was coordinate proofs? And how we graphed a rectangle, but it wasn't really at the coordinates that we said it was. Like we called it B and A and B comma A, and some people were like, "Oh no, that's at 4 comma 0." Yeah, but couldn't B move, right? Remember that? Like that's kind of the frustrating thing is, yeah, this picture's drawn like this, but it's not necessarily drawn accurately or to scale because it could move if you change the expressions, right? And so as long as the lines are parallel, those angles could kind of pivot there. So Grace, I see what you're saying. Did you add them up to equal 180, Grace? Or did you set them equal?
I don't know how I got that wrong because I just solved it again. And I got
so you added them up to equal 180?
Yeah.
Good.
I don't know what I did.
Yeah, as soon as you see M and N are parallel, alternate interior angles are going to be congruent. Corresponding angles are going to be congruent. Alternate exterior angles are going to be congruent. Consecutive interior angles are going to be supplementary. Good. Add up to 180. Okay. So be careful with those. Any of them through 11 you'd like to see worked out? You guys are being shy, or are you really this good? Just that good? I like it. I like the confidence. All right. Number 12, slope. Just find the slope. Y2 minus y1 over x2 minus x1. If you don't know that formula, I'd write it down and study it. And that came up to second period as well. It got a little bit heated. They were mad at me because there's no note card. Okay. Mrs. Wolf and I, we sat down and we talked and we agreed that at this level, the separation between a regular geometry class and honors geometry it's a couple things. One is the pace sometimes. The second thing is the complexity of the questions. And the third thing is you've been identified to be in this class because honor students, you have the ability to acquire and apply knowledge either more efficiently or faster and that's the thing we should challenge you in. Like, honestly, as a teacher, we should challenge. If you have the ability to memorize formulas and apply them, then we should expect you to do that. Okay? Would it be easier to give you a note card? Yeah, it would be easier, honestly. Okay? But my job and Mrs. Wolf's job and honors teachers in general, you should be challenged in certain areas. And honestly, if you don't feel up to that challenge, you have the option of not taking an honors math class. And that's okay. That's your decision. All right. But you've been identified to be in this class because you have the ability to acquire and apply knowledge. All right. And so by us asking you to remember this stuff, it's to challenge you to do your best and teach you that you can learn it. You just have to push yourself a little bit sometimes. And you'll see that in math classes to come. All right. When you get to the AP test senior year, you're not going to be able to have any formula sheet. And a lot of the test is no calculator. And so it's like, okay, where does that transition come? Well, it comes once you're in high school, right? You're in high school. We have to start transitioning you towards that. Does that make sense? I know you don't want, I know a lot of you don't like to hear that, but that's kind of the expectation here. All right. Any other questions? Oh, we're on the new page. For second period, I worked out 12. We got negative 2/3. We worked out 13. Now, when we put this question on the review, this word, and it's my fault for not addressing it earlier during the review. This word, actually, we pulled this question from the old books exam review. So I don't think we've used the word coincide this year, have we? Okay, it's really easy. Are you ready? Do you see how these are two lines? If they're exactly the same, when you solve for y and you put them in slope-intercept form, if they're exactly the same, they coincide. All right? They coincide. Now, what if they just have the same slope, but they have different y-intercepts? Parallel. Intersecting lines have, careful, not quite. Just different slopes. Okay? Think about it. Slope of 3, slope of 4. Are they going to intersect? Yes, because they don't have the same slope. Did they have to have opposite reciprocal slopes to intersect? No. But what happens if they intersect and they have opposite reciprocal slopes? They don't just intersect. They're perpendicular. Do you see how that's not quite right? That's a special case. Yes? Carissa?
So does it matter what B is? Like, if
good question. Do these lines intersect? Yes. Do they intersect and have the same y-intercept? No. This line's y-intercept is up here. This line y-intercept is down here. Correct? Do these lines intersect? Yeah. It's just the point where they intersected is actually also their y-intercept. they intersect on the y-axis. So this line might be y equals 3x plus 2. And this line might be like y equals 4x plus 2. Did the y-intercept have anything to do with whether they intersected or not? No, it just happened to be where they intersected. Okay, on that specific case. So when you look at lines, the first thing you should look at is, do they have the same slope? Well, what's the slope of this line? -4. How about this one? +4. Are they parallel? Are -4 and +4 the same? No. So right there, not parallel, not coincide. Why? Because coinciding lines have to have the same slope and the same y-intercept. They're actually the exact same line. So this one we would just say intersect. Are you with me? Be honest. Are you guys okay with that? All right, next. Parallel. As soon as they told you parallel, you should be looking at this line and saying, I'm going to steal your slope. I'm going to put you in slope-intercept form. I'm going to steal your slope, all right? Your slope is 2. My slope's going to be 2. So when you use this point, and that slope, you put it in point-slope form. All eyes up here for a minute. All eyes up here. This is the line in point-slope form. What would happen if you distribute the 2 and add the 5? It would be in people are whispering it. I can't quite hear you. Someone said it. If you distribute the 2 and add the 5, it would be in. Thank you for speaking loudly enough for me to hear you. I think people said it, but I heard it. I hear the part of slope. I didn't hear anything else. Slope-intercept form, wouldn't it be? Is that point-slope form? No, it's slope-intercept form. Stop here. Stop there. Another one, point-slope form, perpendicular. Perpendicular lines have what kind of slopes? Not just different, opposite reciprocals. So I went to this guy and I'm like, oh, your slope's -4/3. My slope's going to be +3/4. Use that point. How do we do on 16? Okay. Here's what I'll say about 16. You start off with this. You start off with the blue givens. A is parallel to B, and 1's congruent to 3. Question. Right here from the picture. Am I right or wrong? Everybody listen, am I right or wrong? 2 is congruent to 3 because they're alternate interior angles. Nope, I'm sorry, alternate exterior angles. 2 is congruent to 3 because they're alternate exterior angles. Who votes true? Who votes false? Thank you. Why? Because for these angles to be congruent, these lines would have to be parallel first, right? But what if you happen to find out that they're congruent? Like maybe 1's congruent to 2 because corresponding, and 1's congruent to 3 given. If 1's congruent to 2 and 1's congruent to 3, then 2's congruent to 3. Not by alternate exterior because of the transitive property. Oh, look. Those alternate exterior angles are congruent. The lines must be parallel. I just recited the converse of the alternate exterior angles there. How do we feel about that? Been a while since we did on parallel lines proofs. Yes? All right, next page. How do we do on 17? Can you talk about it? Skip it? Why are you guys being so quiet today? You're not usually this quiet. Is it because I hit record? Is that why? Daniela, is that why? Is it because Peyton's not here? Kelsey's not here. Are you sad? Are you in mourning?
Mm-hmm.
We miss you, Kelsey. You think she's listening?
Probably not.
Email me if you're listening, Kelsey. All right, moving on. Oh, look, I see an angle that's outside the triangle. Let's call it an exterior angle. Do you remember the exterior angle theorem? The exterior angle of a triangle is equal to the sum of the two. They use non-adjacent. They use the word non-adjacent. Do you see how this angle would be the adjacent one? These two would be the non-adjacent ones. That's fine. The exterior angle is equal to the sum of the two non-adjacent interior angles. I got asked a lot about this one on the review, so let's go ahead and do it. 15 and 3 make 18. Subtract 2x. Add 6. Divide by 3. I get 8. Angle B. Here's angle B. Measure of angle B is 2 times 8 plus 3. 19 degrees. 19 degrees. All right, 18. That's isosceles, right? They asked us for side AB. But you can't do that yet. You have to solve for x first. You need to set the congruent sides equal first to get x. Then plug it in to get AB. All right? Awesome. Any questions on 20 or 21? On the last quiz, 5.5 through 5.8, we had some triangle congruence proofs on there. One thing I noticed that really bothered me, and I know this, it's not just it bothered me, but you were okay with it. It bothered me, and a lot of people missed it, was when they did proofs, they didn't mark like, oh, these are congruent, and then you put SAS or you put SSA. Danielle, she would never put that. People put SSA, which is not one of them anyway, but they had like SAS marked or back up. They didn't have anything marked, and because they didn't have it marked, they kind of just guessed at it. I'm telling you right now, as soon as you find out segments or angles are congruent in triangles, put a mark on, tick marks, arc marks. Don't just wing it. All right, mark up the picture. Are we doing better now with what's SAS and what's AAS and ASA? How to identify it? Yes? Okay. Ask me if you're not sure. All right, what happens when you bisect a segment? If you bisect a segment, you get two congruent segments. Check your work. If you put two angles are congruent because of because of a segment bisector, we got some issues. All right. What happens if you bisect an angle? You get two congruent angles. I have that on the quiz too a lot. I told you an angle was bisected, and people put that two sides were congruent. Not cool. All right. Lizzie.
On the last one, I had a question. I thought B equals 55.
Did I do it wrong?
Yeah, I think so, because I think you put a 6 instead of a 60. I'm not sure.
Did I? Was it 60?
Yeah.
Oh, thanks. Thanks, Lizzie. That changes things. Here, let me go back through this real quick. All right. At 60, 78. You said
That should be 26.
26. Yep. 26. Measure angle B. 5 times. Nope. 2 times. 2 times 26. Come on. About 55? 52 plus 3, 55 degrees. Thank you. 55 degrees. Everybody catch that? I had a perfect score going on my exam. I'm about to count off. I'm ashamed. I'll try better. All right. Questions about these proofs? Ooh, quick little question. What if you have enough time? Because I'm a nerd. I probably would have done this. I don't know if I would have missed that or not. I might have missed that one if I wasn't careful. I didn't put a 60. If I want to make sure I got it right, I could plug x into here and then get its linear pair and then plug it into here as well and then make sure these add up to 180. Yeah, you could do that. You want to make sure you get a perfect exam. You know who you are. You could do that. All right. It's all good. We still love it. All right. Questions on any other ones up here? 22 or 23? Madison.
I got something different for 22 than the key.
Okay, let's take a look. All right. L parallel to M. What'd you put next, Addison? Let's go through your way.
Okay, I did measure of angle 4 plus measure of angle 3 equals 180 because of the linear, you know? And then I said angle 1 is congruent to angle 4 because it alternates to the
You said angle 1's congruent to angle 4?
Yeah.
Could you put measure of angle 1 equals measure of angle 4? What do you think?
I did that next.
That's fine. Okay.
And I did measure of angle 1 plus measure of angle 3 equals 180 degrees transit.
Transitive or substitution in this case would be fine.
And then I just said angle 1 and angle 3 are supplementary.
Perfect. Curious, what did she put? Did she have differently? Actually, I think I might have printed off the key. Gotcha. Okay. She went consecutive interior, it looks like. She went the consecutive interior angle route. She did 2 plus 3 equals 180 because we know the lines are parallel. And then I kind of like this way. Because you don't need 2 supplementaries. You have a congruent and a supplementary, and it's a substitution. I kind of like that. Good job. All right, any other questions on these ones? 23 pretty easy for you? 23 pretty easy? So just talking to myself today. All right, 24 or 25? We can take this exam right now. Ready for it? Silas, you ready for it? You are? Your cell phone over there, Silas? Where is it?
Yeah, it's over there. So it's right over here.
Close. Number 9.
Oh, I think.
So I had a question about 23. I thought it was 24. But,
Thank you, Alden.
Put definition of congruency, because just on the key it says definition of congruent.
I put definition of congruent angles.
Oh, this one just put definition of congruent. Through everything.
That's fine. Yep. Either one's fine. Carissa.
Did he just ask about 25?
He said 23. You have a question about 25?
Well, yeah, everything was the same to the last step, and I said like DB by says ABC, and Ricky said definition of ABC. I just said definition of
It should be an angle bisector.
Okay.
Yeah, did you put angle bisector? You guys okay with that? Probably you had to do a CP-CTC before that, and then definition of angle bisector. Yeah. All right, this one. You're not asking about it, but I'm talking about it. C is the midpoint of BE. I tell you what, I taught this for so many years. I still do that. I still outline the one they're talking about and mark it. Okay? BC congruent to EC. Question. All eyes up here. Can I say AC is congruent to DC? Reason. Definition of midpoint. No, I'm not told that C is the midpoint of AD. Do you agree? Okay? Are you okay with that? Be careful. And then we're told these angles are congruent. Now, I've had some people get really creative. You don't have to do this. I would have done that I would have done vertical angles. Why are these triangles congruent? They have two A's and an S. Is it AAS or is it ASA?
AAS.
Thank you. Angle, side. It's two angles and the non-included side. AAS. So AB is congruent to DE by CP-CTC, right? Now, I've had some people get creative and say, oh, these lines are parallel. Converse of alternate interior. You don't need to do that. Okay, you don't need to go that far. It's true, but it's not necessary. All right. Let's get through two more real quick. Two more. It seemed like people struggled with 27. But first, 26. Do the sides of a triangle have to add up to 180? No, but the angles do, right? And if this is equilateral, it must be equiangular. You should have set 45 minus 3x equal to 60. Or you could have added up 45 minus 3x plus 45 minus 3x plus 45 minus 3x 3 times to equal 180. But for this one, watch up here. I only know this angle and one of the congruent angles because it's isosceles. Can I set 6y plus 1 equal to 21y plus 13? No. Can I set 6y plus 1 equal to 6y plus 1? No. You'll get all real solutions. But can I say if that's 6y plus 1, this must also be 6y plus 1, and add up those three to equal 180? Yeah, that's the way to do it. All right? So, come ready for chat tomorrow. Last day of exam review. Come with some good questions. Great.
I'm
I'll be right over. Let me stop this recording real quick.